Welcome to an application problem of a radical equation involving the volume of a cone. Harvester ants found in the southwest of the U.S. create a vast interlocking network of tunnels for their nests. As a result of this excavation, a very common above-ground hallmark of a harvester ant nest is a conical mound of small gravel or sand. The volume of a cone of sand moved by harvester ants, given its radius, can be found using the equation r equals the square root of 3v over h pi, where v equals the volume, h equals the height, and r equals the radius. In our next example, we will find the volume of a cone-shaped mound of gravel or sand given its radius. While it would be easier to use the formula here, solve for v, we will use the equation in this form as an application of a radical equation. We're given a mound of sand is in the shape of a cone with a height equal to the radius. We are asked to calculate the volume of a mound of sand with radius 2 feet. From the given information, we know the height equals the radius, so for our equation, h is equal to r, we're also given the radius equals 2 feet. So if r equals 2 feet, because h equals r, h, the height, is also equal to 2 feet. And now to find the volume, we substitute 2 for r and 2 for h in the equation and solve for v. Performing this substitution gives us the equation 2 equals the square root of 3v over 2 pi. And now to solve this equation for v, because the square root is already isolated, we will square both sides of the equation to undo the square root. On the left side, 2 squared equals 4, so we have 4 equals. On the right side, again, squaring undoes the square root, and we're left with the fraction 3v over 2 pi. And now for the next step, let's clear the fraction from the equation by multiplying both sides of the equation by 2 pi. 4 times 2 pi equals 8 pi, so we have the equation 8 pi equals, on the right side, 2 pi is a fraction, has a denominator of 1. Before multiplying, we simplify out the common factors between the numerator and denominator. Notice how there's a common factor of 2 pi. There's 1 2 pi and 2 pi here as well as here, leaving us with 3v times 1, which equals 3v. To solve for v, we divide both sides by 3. Simplifying on the right side, 3 divided by 3 simplifies to 1. 1 times v is v. So now we know the volume v is equal to 8/3 pi, and the units would be cubic feet. So this is the exact volume of the cone of sand. But let's also get our decimal approximation. A common approximation for pi is 3.14, so we can also say the volume v is approximately 8/3 times 3.14, which is approximately 8.37, so an approximation for the volume is 8.37 cubic feet. So we have both the exact volume as well as an approximate volume of the cone of sand. I hope you found this helpful.